Okay, so welcome back. So now what we're going to do is, in this example, we're going to use the nth root theorem, and we're going to find the cube root of this complex number. Okay, so if I want to find the cube root, right, so I want to find the cube root of z, which is going to be equal to z to the 1/3 power. So then what I'm going to do is I'm going to use the nth root formula, which means I'm going to take 8, right, to the 1/3 power. And then I'm going to take cosine. And now what I'm going to do is I'm going to divide the argument by 3. Okay, so I'm going to take the argument by 3, so it's going to be, so let's do this over here. I just want to rewrite this. So 2 pi over 3, and I'm going to divide by 3. Oh, shoot. Divide by 3, right? So this is going to be the same as multiplying by the reciprocal, 1/3. Oops. Which is going to give me 2 pi over 9. So this is going to be 2 pi over 9. Okay. Now, but I also have to add plus or minus, right, 2 pi k over n. Okay, so it's 2 pi over, in this case, 3 times k. Right? So that's going to be plus or minus 2 pi k over 3. Okay, so now I'm going to finish it up. So this will be plus I sine 2 pi over 9 plus or minus 2 pi k over 3. Okay, now before we go any further, because we're not done, make sure that when you're dealing with the k, because now we're going to have to go through k, and the k values are going to be k equals 0, 1, and 2, right? Because n is 3. Make sure that when you plug in the values for k, that you simplify this with getting a common denominator when possible. Okay? So let's do k equal to 0. Well, if k is equal to 0, then we're going to drop everything. And so what happens when k is equal to 0? Then we just get what? This is going to be 3. The cube root of 8 is, or excuse me, I'm sorry, the cube root of 8 is 2. So I'm going to get 2 cosine of 2 pi over 9 plus I sine of 2 pi over 9. Okay? So now if k is 1, then what I get is I get 2, and now I get cosine of 2 pi over 9 plus actually there's no plus or minus, I'm sorry. This is, there's no minus in there. It's just plus. And so then I get 2 pi over 3, right? Because k is 1. So I get 2 pi over 3. Now, 2 pi over 3 is the same as 4 pi over 9, right? Okay? or not 4, sorry. That'd be 6. Okay. So 2 pi over 3 is going to be the same as 6 pi over 9. So we get a common denominator. And so now I'm going to do plus I sine of 2 pi over 9 plus 6 pi over 9. Okay. And then now we can simplify this. So this is going to be 2 cosine of 8 pi over 9 plus I sine of 8 pi over 9 okay, and that's the result when k is equal to 1. And then finally when k is equal to 2, okay, now we're going to add 2 times, right? So k is 2, so this is going to be 4 pi over 3. Okay, so it's going to end up being 2 cosine of 2 pi over 9 plus 4 pi over 9, or excuse me, hold on. Yeah, 4 pi over 3. 4 pi over 3, okay, plus I sine of 2 pi over 9 plus 4 pi over 3. And then of course, again, we want common denominator here, so we're going to multiply the top and the bottom by 3, and that's going to give us 12 pi over 9 here, and of course then 12 pi over 9 here. Okay, and so when we add these together we get 14 pi over 9. Okay, so then our final answer for when k equals to 2 is going to be 2 times the quantity cosine of 14 pi over 9 plus I sine 14 pi over 9. Oops. And that's it. Now again, just going back to the formula, I think when I made a mistake, I don't know if I did this in the previous video when I was writing down the theorem, but it is not plus or minus here. So in the formula, it's just plus. It's not plus or minus. I think I just did that out of habit. Okay, so when you use the nth root theorem, okay, there's no plus or minus in the formula. It's just plus. Okay? Have a great day.